Thank you. Hello. Oh, that's hot. Hot, 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 hot. It happens. Hopefully you can hear me now, Phil, and hopefully I'm not screaming because for some reason that's how I feel right now. But thank you for letting me know. Hi, Vanessa. Glad you could join us tonight. See, I just had to say we were going to get started and the floodgates of how beautiful.
See more people in math than any other subjects.
It's the one. It's the kicker, generally, unfortunately.
That's the one I would try to avoid. If I had to choose.
All right, cool. All right, hopefully we'll still get some more folks. Good. Thank you, Phil, for letting me know. I appreciate it. So before we get into our lesson for tonight, and hopefully everyone saw the link or in the chat or got onto Canvas and signed in and everything. So this is our last week of summer 1 classes. Now, Wednesday is Juneteenth, and NAU is closed, but CCC is open. So do you guys want to not have class on Wednesday and do your practice tests on Thursday, or we can have Zoom only class on Wednesday, and if you show up, you can take your practice tests on Wednesday, but then I would be back in person here on Thursday. No, there's no place for us to meet, unfortunately. Unless you want to, like, come over to my house. Yeah, unfortunately, that's the kicker, and that's why we're here to begin with, because we can't be at CCC because they close too early. And so we could do a Zoom only class, but if you guys are cool, we could just not have class on Wednesday, as long as everyone thought you could for sure come to class on Thursday and do your practice test. So think about it. I know that most of you guys are on Zoom anyway, so it's not really as big of a deal for y'all. Yeah. And so if you just want to come on Thursday night and just know that there won't be any in person on Wednesday night, that's fine too. Hi, Brandon. Good to see you. Does anyone on Zoom need, can everyone come to class on Thursday night, or do we need to do, okay, thanks, Darren. Or do we need to do Wednesday and Thursday? Like I said, it doesn't really affect me too much because I would just hop on Zoom at home and give you guys your codes and you would take your test. So there's not going to be like a lesson or anything too crazy. But of course, it's always nice to have Thursday as kind of the day to kind of decompress and debrief. Okay. I'll think about it a little bit. And let everyone know what we're gonna do. Okay. So then, like I said, so Thursday will be our last class of this session. And then I think, and hopefully you guys can see this, we'll probably not have classes for the next 2 weeks. And then our summer 2 classes will resume on July 8th. And it'll still be Monday through Thursday, 5:30 to 7. And I'll give you guys more information probably tomorrow or Thursday, but just plan on that. And so next week and the first week of July, even though we're not going to meet on Zoom or in person for class, if you wanted to come take a practice test or work with me one-on-one or something like that, I would be available. We're just not going to meet like this for class. Oh, thank you, Brandon. I thought I sent it to you in the Zoom chat, but I'll send it again. Maybe you blipped out there. So there's the sign-in sheet. Hopefully you get it this time. And so probably for summer 2, we'll kind of go back to a similar schedule to where we'll have 2 nights of language arts and 2 nights of math. Um, and we'll be working on kind of a foundational curriculum that I think will be really good, so that hopefully when we start in August, we can get into the nitty gritty. So hopefully that works and sounds good to everyone. If you have any questions, definitely welcome to ask. All right, if not, let's start off. So we're gonna do 2 math lessons. Whoa, hello. Noisy screen. We're going to do 2 math lessons. So tonight we're going to talk about probability, which actually we had talked about for our second science lesson as well. So it kind of builds from there, but of course, mathematics, it's going to get a little bit more complex, but not too crazy. So we're going to start with our probability unit. And so let's see, I'm going to hide you guys. All right, and so page 1 of our activity, our warm up here. Hopefully I can get on the screen without it being too small. All right, so on our first sorry guys. So there's 10 events on this list, okay? And so what you need to do is order each of the events from 1 to 10. So you're gonna read through the 10 events and decide 1 is gonna be the most likely thing that could happen, and 10 is gonna be the least likely, okay? So as you read through the list, you're going to begin to put them in a rank and an order, and saying 1 is the thing that would be the most common or the most likely to happen. And then all the way through 10, 10 is going to represent the least likely thing to happen. Okay. So I'm going to give you guys a few minutes to work on that. Okay.
Has the highest, like, it's gonna happen, or is 1 low?
No. 1 is most likely, 10 is least likely. So the most impossible thing should be a 10. The most likely thing would be a 1. Okay? Does everyone on Zoom understand this little warm-up activity? Hopefully it makes sense what to do. So just try and read through those, put them in a good order. What do you think is the most likely versus least likely? Woo. No, you got them all listed out? Okay. How are you guys doing on Zoom? You got your events all ordered? Or does anyone want or need more time to put the 10 events in order from most likely to least likely? Okay, thanks, Vanessa. Appreciate it. Okay. So does anyone, what did you guys say was your number 1, the most likely of these 10 things to happen? Okay, a grizzly attack in Yellowstone? What do you guys think on Zoom? What's your number one most likely thing to happen? Or do you guys agree with Nick? No? Brandon, you got a guess? Not sure? That's okay. Okay, Phil thinks being struck by lightning. That's a pretty good guess too. Anyone else got a guess? Okay. So pretty close, Phil. Fortunately, getting attacked by a grizzly is not the most likely thing to happen among the list of things on here. Actually, let me see if I can get this to work. Why is my brain hurt? I know. It's awful, isn't it? I know. So, oop. Oh, well, that's no good.
You're
Okay.
not gonna win the jackpot. There's no way.
Good. Good. But actually, Jay is our number one. Well, well, it really should just be a 1 in 365 chance that you'd meet someone with your birthday. And so it's still not very likely. 1 out of 365, right? If we look at it, right? If we take 1 divided by 365, right? It's 0.002. So that's actually 0.2% probability. So it's still very unlikely, right? 0.2% probability. Okay. So when we're working with a probability, we create a fraction. And so we say 1 out of, right, 1 birthday out of 365 days in a year. And so that's our probability, 1 in 365. Okay, so we take kind of our desired outcome, which is the same birthday, right? 1 day out of the year, over the total possibilities, right? The total length of the year. Right, among these 10 events, right? There's definitely things more likely than a 1 in 365 chance. All right. So then actually this one's kind of fun. G is number 2. So it's the next most likely event is that we would be born with 11 fingers or toes, and that is a 1 in 500 probability. Huh? You put that as the least likely? Apparently it's kind of weirdly common-ish. And actually, of course, Ryan this morning said he had a cousin with an extra finger and a cousin with an extra toe. So I was like, well, your family's just really exceptional. Yeah, it doesn't feel like it's very common because I don't think I know anyone with an extra finger or toe. I don't know if I know 500 people. I feel like I could probably interacted with over 500. I'm really bad at estimating. That's probably why I'm not good at math. I was like, I don't know. But so once again, right, we have a 1 in 500 chance. So you could also think about it as a fraction, right? 1 in 500, which is often the way we're going to start by creating probabilities, is by creating a fraction. And then like I just showed you guys, on your calculator, you're just going to take the top number of the fraction 1, divide it by the bottom number, and then we're going to move our decimal point over. And so it's still a pretty small chance, right? A 0.2% chance, right, of being born with an additional digit. Okay. F is 3. So finding a pearl in an oyster is a 1 in 12,000 chance. Okay, so yeah. And so, right, we'd have to collect 12,000 oysters, and probably only one of those 12,000 is going to have pearl. Yeah. And of course, we know that pearls are, well, natural pearls, I guess. Hmm, I guess they're uncommon. I don't know. I don't wear fancy jewelry, so. um, but of course, I also know that they can farm pearls now. So I think if you were on the pearl farm or the oyster farm, then I think this is for like wild oysters. All right. So Phil, your choice for number 1 is actually the 4th most likely event. So it's still compared to more over half of these other items, it's definitely common. So our chance of getting struck by lightning is 1 in 15,000. Whoops. 1 in 15,300. And so once again, if we put it in the calculator, it's going to be a really small number, right? Oh, yeah. So it's like, you know, very, very, very small chance. And this E minus 5 is saying basically we would have to move this decimal point 5 places over. So it's like 0.006% chance, right? With our birthday, it was like 0.2% chance. Here it's 0.00. That's okay. I mean, once again, we definitely want it to not be a likely event. And of course, you could do stupid things to exacerbate those chances, but all right, next is blue lobster is our 5th most likely event, which is a 1 in 2 million, right? So we need 2 million lobsters, right? And then we might eventually find one blue lobster. I have seen blue lobsters before. I feel like it was more common than what that number says, but we'll just go with the paper's number. Okay, so then grizzly bear attack is 6 on our list. And fortunately for us, right, there is a 1 in 2.7 million chance of getting attacked by a grizzly bear in Yellowstone Park. So that's good, because I don't think you want to get attacked by a grizzly bear. Generally pretty bad. Just watch The Revenant. That's good bear attack.
I was thinking that was number 1 of happening.
Well, and I mean, from my understanding, like the buffalo and the elk and some of the other wildlife at Yellowstone are way more dangerous, and tourists are dumber about are more likely to get injured by those types of animals because they're more like visible and accessible. I'm trying to think.
Walk up to your campsite, your camping tent, whatever you're in, they'll walk up to it, they'll get around it. That's why I was thinking that was number 1, because it can happen anywhere.
Yeah.
Not just Yellowstone.
True. Although Yellowstone does kind of make it more specific, but
yeah.
All right. So actually, right, we're more likely to be attacked by a grizzly bear than a shark. I don't know if that makes you guys feel better, but there's a 1 in 3.75 million chance of being attacked by a shark. So hopefully that makes you guys feel better. We're more likely to get attacked by a bear in Yellowstone.
Also, I don't think people are increasing his feet go way out there. Come back.
Yeah. And I mean,
last time I was in Cali, I was way out. Like you could barely see the beach. And I was
yeah, I'm not a fan of super open water.
I
Trips me
find
out.
it fun.
My brother used to scare me because he would swim under my uncle's boat when we were out in the ocean. I don't know why. I always got worried that he wasn't going to be able to swim all the way under the boat for some reason. I don't know. Freaked me out. And I was like, no, I'm not swimming under that boat. I'm going to get stuck.
I went with my buddy. He's like, I couldn't even see you. And I was like, yeah, I was way up there.
All right. Finally, number 8 is a plane crash. So once again, pretty good that this is a very small chance, which means hopefully that our airline travel is very safe. I was actually thinking about that today. I feel like there's way fewer plane crashes than there used to be.
It's just the guys that were alive around 9/11.
I mean, that's really no, I mean, planes crash, but luckily it's pretty rare, pretty safe to fly. Number 9 is our jackball or Powerball. Sorry, jackball. That's funny. Powerball jackpot. Sorry, you guys clearly see how much I play.
I wrote 8 on that.
Good, you were pretty close. So you have a 1 in 292 million chance of winning the Powerball jackpot. So not very likely at all. And then I don't know if you guys remember this or have watched any of the documentaries, but the least likely event is the winning the $1 million prize when McDonald's had their Monopoly game, but it actually ended up being a scam that they rigged. So
I had that number.
okay. And so when this was a thing, still had basically about a 1 in 451 million chance of winning the $1 million. And so good. So one thing to notice, right, is that all of these probabilities have a 1 as our kind of our baseline. And then as our bottom number gets bigger, right? If we think about it as 1 over 500, right? The bigger the denominator, it's going to be, right, less likely, okay? And so these are all very, 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 very unlikely events, okay? Is everyone feeling good so far? Kind of understanding the concept? And so the thing to remember is we're probably going to be dealing in fractions and percentages. But let's keep rolling if everyone's good. Did everyone get everything down on the first page that you needed? All right, let's look at page 2. Oh, okay, thanks, Phil. So there is a video link up here if you want to hear a different and probably better explanation of probability, how it works. But let's go ahead and take a look here at what we've got. And so probability is, right, how likely something will happen. Okay. So 0%, right, basically means that it's not happening. 100% means it's certain. Okay. So when we look at, or when we think about probabilities, we're always going to kind of have it on a scale, like you can see down below. Okay. So as I said, when we look at these numbers mathematically, they're generally going to be expressed as a percent or a fraction. The way I was writing it up here on page 2, it's kind of how we would say it if we're speaking the probability. Also, sometimes instead of the word in, they might just put like a colon. And so you might see that too. So if you see the little 2 dots like that, then hopefully that's another way of writing a probability, 1 in 365. Okay, but generally we're going to be working with percents and fractions. Now, one of the nice things about our, and I don't know if I can do it on here. Whoa, that's not what I wanted.
You have to go into-
Yeah, this isn't gonna give me the right calculator.
calculator, figure it out.
Oh, it's okay. I have a calculator. I just wanted to be able to show it on the screen. That was all. No biggie, but so on the GED calculator, you can use and create and work with percents. If you start with a percent and you need it as a fraction, you write in the percent, hit these two little triangle keys and then enter. And then if you want to go back to the percent, then you can do that too. But let's jump down here, okay? So when we're talking about a probability, we start by looking at the situation and deciding, okay, what do I want to have happened? What is my desired outcome versus how many possible outcomes there are, okay? So for an example that we see often, you can always think of a dice or a die, right? We have one 6-sided die. And if we want to roll one of those 6 numbers, right, then that would be our desired outcome. If I want to roll a 2, right, there's only one instance where that's going to happen with my dice roll. Okay. However, of the total number of outcomes, right, there's 6 possible outcomes, 6 possible numbers. So the chance of me rolling a 2 on my dice is a 1 in 6 chance, or about a 16% probability. So it is actually falls into this area of unlikely. Okay. It's unlikely that you would roll the number you want unless you're cheating. Okay.
You just be good with the dice. Know how to toss it.
That sounds like cheating. So you can always think about probability as kind of existing on a spectrum like this. And so 0 is our bottom end. That equals the impossible. 100% is our absolutely certain. Okay. And then, right, anything kind of between 1% and 49% is going to be considered unlikely. Although the closer we get to 50, the more likely it's going to be. But in general, it's still not going to be very likely. Okay. In the very middle is what we call even chance or 50-50 chance. So that's when we think about flipping a coin, right? Our coin has 2 sides. We want either heads or tails. So that's one desired outcome and 2 possible outcomes. And so if once again we have a truly fair coin and a fair flip, right, we really have an even chance of getting either heads or tails. Okay. So 50-50 right down the middle, we can't really say it's absolutely likely, it's highly unlikely. It's even. Okay. But then as we move from 51% up to 99%, we call that the likely kind of zone, right? So when we're over 50% probability, it is pretty likely to happen. We can be pretty confident. And so here, right, if I had, I guess we could think about these as marbles or balls, but if I have 4 red and 6 total balls, I would have a 4 in 6 chance, right, of selecting a red ball, which equals a 66% chance, right? So it's hopefully you guys agree it's much more likely to choose, you know, 1 of 4 out of a total of 6 than it is to roll that number or win the coin toss. Okay. So hopefully that feels good. Does anyone have any questions about probability and this probability line to kind of get a sense of stuff. You guys good? All right. So let's just look at questions 1 and 2. Who can tell me what would be an example of something that has a probability of 0? What would be impossible?
Being able to fly without like, no, nothing.
Mm-hmm. Yep.
No plane, no.
Right.
whatever.
So,
Or levitate, there you go.
did someone say levitate? Yeah.
Hi, Dave, we had one woman, now your generation wonders if it is a woman. That's fine. I'm sorry.
How about, does anyone else have any good examples of something that has a 0% probability? Anyone on Zoom got an example?
Getting a flat tire in under a minute.
Mm. Have you ever driven over a spike strip? Or is that a blowout? It's not really like a,
Spike strip would be like if
it would like puncture it and wouldn't the air go away quickly?
spike strip is only like if you're in a chase though with like cops,
Oh yeah.
they block off.
Or those parking lots if you go out the wrong direction.
Yeah, I guess, okay.
You know. All right. How about 100% probability? What can we be certain of? Anything?
Oh,
Uh,
losing your wallet. I lose my wallet on a daily. I have to tear my bedroom apart just to find it.
maybe something a little less personal. So I would say something like,
Seeing a white car on the street.
okay. Hmm.
Or sunset, that happens every day. That's
Yeah, I mean, I can be pretty 100% right that the sunset is going to happen in the west, right?
south.
No,
It rises in south.
it rises in the east.
Vice versa.
Not sure.
Finding a white car on the road.
Mm, I would say that's really, 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 really likely, but it's probably not something we can be certain.
There's a white car in the parking
Okay.
lot. Yeah, let's do it.
At least at this current moment, I'm pretty certain my heart is pumping blood around my body.
I don't think you could be with your top here now, but whether
Yeah, I agree. Right? My lungs are inhaling air to provide oxygen to my cells. So we kind of think about those like scientific facts and stuff that we talked about before. So, pretty certain that the gravity on Earth is a certain number.
very certain we're gonna have class tomorrow.
Thank you for that. I like that optimism. So hopefully everyone feels good about that, but let's actually jump into the math, okay? So remember so for all of these probability questions, there should always be 2 pieces of information we need to put together to create our probability. So what do we desire to happen over what are the total number of possibilities? So if we have a deck of cards, standard deck of cards has 52 cards total, 4 suits, right? 13 suits, 13 cards in each suit, 2 red suits, 2 black suits, okay? So if we look at question number 3, what's the answer? What is the probability of drawing a red card from the deck? Well, how many total red cards are in the deck? There's 26, and how many total cards are there? 52, so 26 out of 52. Can we reduce that fraction? can we take something out of the top and the bottom to make this a more easy fraction to deal with? Anyone on Zoom's welcome to help. You can put it in your calculator, if you want, right? So 26, no, well, I mean, you can make it a fraction, or you can just take your numerator, your top number, divided by your bottom number. And 0.5, well, 0.5, what is 0.5 as a fraction?
Zero, 0.5.
No.
Bad. Oh, as a fraction.
0.5 is the same as 1/2, right?
Oh, yeah.
So 26 52nds is equivalent to 1/2. Does that feel okay? Yeah. And so, yeah, if you went into your calculator and did the fraction button, you know, the N over D button. Click, yeah, it shouldn't, no, just the N over D key, and it should give you a little fraction. Put your 26 in top and your 52 in the bottom. Does it say 1/2? Then hit second and then close. Good. So 26 out of 52, right? So there are 26 possible red cards out of the 52 total cards. We can reduce that and then, right? So, or.
So actually, there is 52 cards in a deck, but you take out the jokers, and you take out that one extra card. So actually, instead of 52, you add 49.
Yeah, I guess we're assuming we already did that. And we're not playing Pinochle. Although I don't. No, I'm not gonna think about Pinochle right now. So hopefully everyone sees, right? 26 is our desired outcomes. 52 is our total possible outcomes. And basically, right, because half the deck is red and half the deck is black, we have a 50-50 chance of when we pull that first card that it would be red. What would be the probability of drawing a black card?
6. Well, you see, you have 13 red, 13 black, and 13 black. It's the same thing. It's 26. You have another.
Oh, sorry. Yeah. So it's the same as answer 3. Yes. Sorry.
I was like, wait, what do you mean?
Well, say it as a probability. It's still a 50-50 chance.
Yeah.
That's more helpful here.
Okay,
Yeah. So the 26 and the 52 get us to the 1 out of 2 chance or that 50-50 chance. Okay. So yeah. Okay. Now, if we move to question 5, what is the probability of drawing an ace from the deck? Let's see.
What you do is you take that 52 divided by 4, it's 13. Take that.
Well, we have the whole deck, right? And so you're right. There's 4 total aces and we want an ace. How many total cards are there? Yep, good.
7% chance. So if we do.
Well, if we reduce the fraction, right? 4 over 52. Reduce that fraction.
A 1 in 13 chance.
Right, good. And then what is 1 over 13 as a percent? Second, and then that close parenthesis.
7.69.
So about 7.7%?
Yes. 7.7.
Good. So wasn't it 7.69?
I did that right.
Yeah, I would just round that.
So we could just do the rounding, yeah, we can round it to the nearest, but you can do it.
Yeah, just round it to the nearest 10th or so. Should be fine, but good. So of course, hopefully you guys would agree, right, that there's fewer aces in the deck than there are red cards or black cards. So that's going to be a much lower probability of, right, that first card being an ace. Okay, which is of course why, right, 4 aces in poker is pretty darn lucky and amazing, right? Because it's super unlikely. And actually poker, I guess when they used to show poker on TV in the long ago, I don't know if they still do, but they used to show the percentage of the probability that someone had to win based on kind of the hand they had. Maybe I just dreamed it. Okay, how about number 6? So we either want to draw a red king or a 2 of spades. So how many total possible cards do we want out of the 53 or 52? Good. But we only want to draw either a red king or a 2 of spades. So how many total cards is that? How many red kings are there? 2. And then how many 2 of spades are there?
There's
2 of spades.
the 2, like number 2,
Yes.
and the spade, yeah.
There's 1, 2 of spades. So
Oh, yeah, you got the heart, you got the clover, okay, yeah,
Mhm.
got it. Okay, so.
so that means that our desired cards are 3, right? Because we either want to draw one of the red kings or the 2 of spades. So we now have 3 desired outcomes.
3 under 52.
Mm-hmm.
Of 5.7% chance,
Okay.
would that be right?
Because I don't think 350 seconds doesn't reduce.
No.
So 3 divided by 52. Ah.
Yeah, 5.7, yeah.
Yep.
So I did that correctly,
Mm-hmm.
correct?
Mm-hmm. Mm-hmm.
Perfect. So what would 5.7% be in?
What's your question? Okay. How are you guys doing on Zoom? Is this making sense how to create the probability, make it into a fraction, and then
Yeah, you'll just
reduce it? You don't necessarily have to reduce it to convert it into the fraction or the percentage, but
So all you would basically do is just take your, whatever your answer is, like the king, the spade, and then just, yeah, you would divide that by whatever your other.
yep, because you just, like I said, there should always be the 2 pieces of information. What do we desire for the outcome to be? And what are the total number of possible outcomes? So yeah. All right. All right. Hopefully you guys are still with me. All right. All right, let's keep going. So of course, you know, not going to be so simple as to just make, you know, one fraction and stuff. So now we're going to look at if we have a probability, but now we're going to talk about a series of events, okay? So now we're going to do 2 things and we want both of them to happen, okay? So if you look at the first example here, I'm going to roll the dice. I want to get a 4 and I want to flip a coin and get heads, okay? So let me see if I can do this. So, right, the first event, actually, here, let me stay in PowerPoint. So our first event, right, is rolling a die and getting a 4. And then our second event is flipping the coin and getting heads, okay? So if I want to get a 4, that's one number out of 6, okay? So my first event of rolling my dice, it alone has a 1 in 6 chance, but I want to do that and flip a coin and get heads, which is a 1 out of 2 probability. So when I have 2 events, I calculate the single probabilities of each event as a fraction, and then I multiply those 2 probabilities together. Okay. Luckily, multiplying fractions is easy. You just multiply the top numbers across the top and the bottom numbers across the bottom. So if we take our roll of the dice, our 1 in 6 chance times our coin flip, a 1 out of 2 chance, 1 times 1 is 1, 6 times 2 is 12. So for both of those to happen, I have a 1 in 12 chance. So, right, the more events I kind of stack into a sequence and I want all of it to happen, it really becomes less and less likely. Okay? So then if we were going to do number 1 here, what is the probability of flipping a coin 3 times and getting heads every time? So think about what is our probability of 1 heads, and then we'll have to multiply that probability times itself 2 more times. So let me know if you think you figured out the answer. So we have 3 50-50 chances, but then we want to combine them together into a series of events as opposed to one individual event. What's your fraction? 1 times 1 times 1 is 1. 2 times 2 times 2. 2 times 2 is 2 times 2 is 4. 4 times 2 is 8. So do you guys see how that works? So you just create your individual 1 in 8 chance. Oh, close, Phil, but do you see why it's 8? Because we're multiplying. We're not adding, we're multiplying. So 2 times 2 is 4. 4 times 2 is 8. So it's actually going to be a 1 out of 8 chance, which is, did you get the percentage? 1 out of 8. That sounds good. Yep. Oopsie doodles. Good. Okay. So yeah, just make sure that you get each individual event's fractions and then multiply. And remember, you're multiplying, you're not adding. Multiply your numerators, multiply your denominators. And just like we've kind of seen before, right, the more events we sequence together, right, the probability drops. And so actually, right, the first event is less likely because that's only a 8.3%. Oop. Okay. All right. But of course, what you can see here is that when we have multiple events, we can have kind of two situations. And so we have to be ready for that. Now, the steps aren't going to change, but our numbers are going to be affected. So, right, we started out tonight just looking at a single event. That's just that one event, one roll of the dice, one flip of the coin. But then what we just looked at was a series of events that don't affect each other. Okay. Right. My dice roll is independent of my coin flip, but I'm putting them together. But we'll also get an example of a series of events, that do affect each other. Okay. But let's go ahead and start back up with number 2 and we'll build up to that final scenario. Okay, yes.
So that is a 212.5% chance to draw on that marble. Does that sound okay?
Well, how many total marbles are in the
17.
bag? And so 8 out of 17? Is that what it is as a percent?
I did 17 over 8 and then did it.
Why is the total number of marbles on top? Right, because we want a green marble out of all the total marbles.
8 over the 17.
Yeah.
Okay.
Because if it's over 100%, right, then it's off the charts as far as probabilities go. Yeah.
So then if we do it the other way, if we just do 8 over 17,
Mm-hmm.
47% chance.
Yep, that sounds about right. Because
Okay.
17 is a little more than half,
Okay, so
or
just
little.
what they want to see on the top of
Exactly. Yep.
Okay.
Yep. So good. So what we want is, right, one of the 8 green marbles, right? So that's like our desired outcome. And then we take our total possibility, 17 total marbles. Okay. So good. Okay. Now, okay. So what we need to look at here for number 3 is this idea of if the events don't affect each other, you'll see something like this. Chad randomly selects a marble from the bag and puts it back, then randomly selects another. Okay. Does that make sense? Why that is similar to the situation we just looked at. Okay, so he has his bag of marbles, he takes one out, it's green, he puts it back in and chooses the next one. And the next one he wants black. So our first probability stays the same, right? 8, right? 8 out of 17 to get my green marble. And then how many black marbles are there? 3, and so 3 out of 17. Good. And then multiply.
17.6% chance.
It should be a lot lower than that because basically, here, I can't, it's hard to type fractions like this, but remember, did you type it in? But,
right?
well, yeah, so you found this is 17.64% chance is the likelihood of choosing a black marble.
Okay.
But remember, we want to first choose a green, throw it back in the bag, and on our second choice, get a black.
Oh, okay.
Okay. So you're on the right track. But now, because we have the 2 events together, we have to multiply the probability. So we're going to
take that 47 times or divided by that 17.
47.
That percent chance.
Oh, don't deal with the percentages. do the math with the fractions and then convert it to a percentage. Yeah, doing math with percents like that is gonna mess you up. So stick with making your fractions first, your probability fractions. And so remember, here's our green marble and here's our black marbles. And so we end up with 24. I have to do 17 times 17 on my
Oh,
calculator.
8 times 3 and then 17 times 17 on
Correct.
that, 24 and then 17.
So out of 289. Okay.
And then we'll take that 24 over that 289.
Mm-hmm. And then convert it to a percentage from there.
Over that 289.
Mm-hmm.
And that was this 8.3%.
Mm-hmm. Yep. So yeah, when you have the multiple events, keep them as fractions until you do the multiplication.
Remember, times those guys and times those guys.
Mm-hmm.
Okay.
8.3%. Okay. So hopefully that works a little bit better. So this was our probability of our green marble, but because Chad put his first selected marble back in the bag, right? We have the same total number of marbles for both events. Okay. I'm gonna have to erase my purple writing. So does anyone need me to not do that yet?
I just like times 2 and then times 5.
And you could put both of those in the calculator times each other. So you could make the first fraction and then hit time, make the second fraction, enter, and it would do it for you.
Okay.
And definitely let the calculator do the heavy lifting, unless you're Brandon. Okay, so now if we look at number 4, let's look at where the language changes, because now we're going to look at a series of events that do affect each other. So what I do in the first event affects my second event. Okay. So here in scenario 4, Chad randomly selects one marble and then another without replacing the first, right? Why are you subtracting 2?
Well, he took out one and he took out another one without replacing it.
Well, okay, so in the scenario 3, he chose one, put it back in the bag for the first one, right? And then chose the second. In this situation, he chose the first one, but he didn't put back in the bag. He set it like outside. So then on the second chance, how does that affect the second probability? Because now we have one fewer marble in the bag. So our first probability stays the same, 8 out of 17, but then instead of 3 out of 17, what would we have?
Out of 16, right?
Well, we want black, which is 3 out of 16, because this on the second draw, the total number of marbles has gotten smaller. Yep, good job, Darren. So, like I said, it's really important that if you have these multiple event probabilities, that you understand, okay, are they separate events that don't affect each other? Or like we see in 4, right? Because I've pulled one person out of the total in the first event, it affects the numbers in my second event. So what is 8 17ths times 3 16ths? Well, I always like to multiply it out first, but I suppose you wouldn't have to. Whoa, that was loud. Sorry, guys. The mic is hot. So 8/17 times 3/16. Mm,
28/50.
Interesting. I got 3/34.
Oh, I did that. I did the 8 about 17, and I did that 17 by 3/16. Yeah, I did that backwards.
Okay.
My bad.
Oh, good. Thank you, Darren. No worries. So 3/34, which is about an 8.8% chance. Oopsie. Okay. So hopefully that feels good and makes sense. And so these are the three possible outcomes that you could have. Okay. So is it just one event? Is it a series of events that don't affect each other? Or is it a series of events that does? But when we have that series of events, create the two single probabilities and then multiply those two fractions together to get the events probability. Okay?
Good.
Questions? All right, let's see. Just for fun, what's the probability of drawing a yellow? 0% chance. Good.
White, there's no yellow.
Exactly. Exactly. We would have to have a whole new bag to 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 try to work on that. So yes. And they might throw something in that's like silly and obvious like that. It always makes you feel good when you're like, ah. I took a rock and roll history class and question was the basis for the doors? And I was like, you little, there's an organ. I was like, oh, that was a good one. What's his name? Can't remember. All right. So go ahead and jump ahead to, so on pages 4 and 5, there are some practice problems. So why don't you guys go ahead and spend some time on your own working on these 2 pages of problems, okay? If you need to do the problems on my screen, let me know. And I can move stuff around. If not, go ahead and work on that as best you can. And remember that it's really important to note, whoopsie doodles. Wow, sorry. It's important to note the language in the questions, of course, right? So in addition to cards, dice, and coins, spinners is another pretty common thing that they do with probabilities. And just think of like a game, the game spinner thing. Like I guess the dial one in life is kind of fun. Or the pop-o-matic trouble.
Right.
Um
So for number 1,
mhm,
looking at it,
mhm.
that would be B, right? Because there's 3 even sides on dice, right?
There are 3 even numbers, but how many total bases are there?
6.
So 3/6 is not 1 out of 3.
Okay.
Can you reduce 3/6? Mm-hmm. Mm-hmm. Yep.
Okay, so you gotta redo that.
Right. So we have 3 desired outcomes with 6 total possible outcomes. But we want to know the chance of not getting white. For number 2, 3 out of 5. It needs to be greater than 20%. So over 50%, right? If it's 3 out of 5. So 3 over 5.
But 3/5 is that.
Because remember, we don't want white, so there's 3 blue sections. We want to land on blue, but there's 5 total sections. Mm-hmm. Mm-hmm.
Desired outcome would be 5 and our possible would be 3.
No, other way around, right?
Desired would be 3 and our possible would be 5.
Right. The bigger number should always be on the bottom of these fractions because they're representing less than 1 or less than 100%. You folks on Zoom feeling good about these? Are they making sense? Good. Thanks, Phil.
It would be a 40% chance, right? For 3.
Mm-hmm.
And then that would be have a desired of 2 outcomes and possible.
For number 3?
Yeah.
We have 8 desired and 20 total, right? 8 out of the 20 pennies. Mm-hmm.
Maybe 12% support.
Yep.
That would, for number 5, that would be B.
Hmm. Well, looks to me like over half of his hand has a value equal to or greater than 4. I see 6 desired cards that fit that criteria out of 8 total cards. So it can be 4 or higher.
That has to be below 4. So there's
No, it has to be 4 or higher, equal to or greater than 4.
6 cards.
Mm-hmm.
So out of the 8, so we'll go 6 over 8, right?
Mm-hmm.
And then we should get our, we run it out of 75. And we take that 75.
Do the 2 little triangles by the enter key. If you have 75%.
3/4.
Yep.
So
Mm-hmm.
you just take 5. Oh, okay.
And so if you had just, Nick, if you had just done 6, 8, and then hit enter, it would have given you 3/4.
6. What's 8?
No, make the fraction 6 over 8
Okay.
and then just hit enter.
I did the hard way. I turned it into percentage and then I turned that percentage.
Yeah, so you also have to kind of look at, I guess, your answer choices. And if the answers are in fractions, then you don't need to worry about the percents. But
One card is drawn for. So we just do 1 over 250.
yep. And
And that should give us what we wanted. Well, not all the way. We have, okay, so it comes in that. And it's not that, so if we do 1 over 2.
just look at your answer choices. You shouldn't need to do any calculating.
Alright, I wanna
Okay,
get the feel for it.
Sure.
Right?
sure.
Unless that's,
You can do it that way.
I just kinda wanna get the feel for it.
Mhm.
I wanna like, I wanna learn it.
Mm-hmm,
I
mm-hmm,
wanna like
mm-hmm.
understand.
No worries.
That's that, then do that. That is 0.4%, so. It's 1/250, right?
Mm-hmm. Yep. And so, like I said, that colon is another way that you can write a probability.
I mean, the answer was in itself then, 1 out of 250, you put in here, it's 1 over, yeah,
Mm-hmm.
to 4%, you bring that 4 back down to the round or whatever, it brings you to 1/250.
Mm-hmm,
So
mm-hmm.
it's already there.
Yeah, and you know, the percent and the fraction are equivalent. It's just we're representing a number less than 1 and greater than 0 in 2 different ways. More questions?
Oh,
So I think these are the ones that have a series of events now. Potentially. So Talon flips a fair coin and rolls a fair die. So we want to get heads and an even number.
point at that has 6. So we'll just do 2 over 6.
Well, the first event is the coin toss and he wants heads. So that's a 1 out of 2%. Or sorry, 1 out of 2 chance. And then what about getting an even number from rolling a dice? What is that?
That is a 1 out of 6.
But an even number, how many even numbers are on a dice? Good. So times 3 over 6. And then we have to multiply those two together.
and the quarter.
Oopsie, I totally did that wrong, didn't I, Brandon? Thank you. Yeah. I just can't seem to multiply 1 times 3. Good. Thank you, Brandon. Just making sure you were paying attention. You did good. You passed.
And it's some kind of marble.
Yeah. And then you would just reduce that, Phil. Are you good with seeing that 1/4 is the same as 3/12?
10 marbles. And then 2 white, we're gonna go, for 10. And for that, to get our percentage, or we should do one, no, let's do the 1/5, right? Yeah, 1/5. We'll come back down, we'll go. 1/5, and then. Get it's 20, it would go more with 40 times 1 and 2 chance. And again, we'll get the. Right?
Yep. Correct. Good job.
We're back down to 10 marbles.
But she keeps it out of the bag, right? Well, there was 10 on the first time. And then there'll be 9 on the second, right?
There was a 10% chance first time. And it's about marbles to otherwise. Then she ran into trouble. But probably gonna lose control of the play.
Okay.
So she has 3 reds, 2 whites, and 5 blues. She draws another white, and then another red. So then we'll go the 2/3. Red.
How many total marbles did we start with? So 2 out of 10 will get me my white marble. And then if I keep that white marble from the first time out of the bag, how many red marbles are in the bag and how many total marbles are in the bag?
3 red and 9.
Mm-hmm.
So 3/9.
Mm-hmm.
So if we do this, we do this, I do this.
Yep.
That's it.
So yeah, you really just have to kind of keep the events, find the 2 events and decide, okay, are they related or not? Do they affect each other or not? And then what's my first event's probability? What's my second event's probability? As fractions, multiply those fractions together. Yeah.
You see why I need help? Oh my god.
Well, and hopefully you guys are agreeing now that you've kind of seen these probability problems. Like, hopefully you are feeling like, okay, now that I actually have done this and we practiced it a little bit, I feel like I know what to do. That's kind of our goal. And remember, this is one of the areas where like everyone who takes GED math is not as successful as in other areas. But once again, if you know what it's asking, it should be pretty
So number
pretty
4
easy.
be 25%.
Mm-hmm. Yep.
Next. Then without returning it. second card, where's the probability of affecting six and then four? So we make our card, we turn eight.
Right, we're gonna choose a 6 on the first one, so what's that hand of cards? And how many sixes are there?
We have 8 cards and 1 6. But then you take
Mhm.
2 cards, so we have 7 cards.
Well, that would be for the second one, right? So the first card, he has 8 cards in his hand and we're choosing only one, right? There's only 1 6 among the 8. Okay. Times, and then what's the second event is, right? He's gonna choose a second card, but he didn't return the first card, so how many 4s were in Max's hand?
1 6 and 2 4s. Right?
Well, okay, so choosing a 6 is our 1 out of 8 chance, that first event. Right? And then the second event, I'm going to choose a 4, but there were 2 4s in Max's hand. So there's 2 possible cards that the friend could select on the second time and get a 4. But because he didn't return the first card, we have 7 remaining.
2 over 7, correct?
Yep.
1.8. So C. Right?
Yep.
Okay, so you just gotta
It's
on that.
That's okay. And like I said, number one, these problems are worded in a challenging way. So you kind of have to be aware of the 3 possible situations, and then you just try and find that information, right? What do we want versus what is possible in each um scenario. Mm-hmm.
Plus 12 equals 100. There's 100 as follows. Randomly takes out a ball. And takes out another ball. Out of the first one. They take out a ball. Then he copies it. Then takes out another ball. So that's -2. So then that's 98, right?
Okay, the coach randomly takes a ball out of the basket and serves it. Then she takes another ball out of the basket without returning the first one and serves it. So 2 serves, right? So the first serve, what is the probability that the first one was a green ball? Would be a what out of what?
Green ball, there's 20 out of 100.
Good.
So we're gonna go through this.
Mm-hmm.
We're gonna go this 20 over 100.
Mm-hmm. And
There's
then,
a 1/5 chance
okay.
for a 0.2% for the green, right?
Mm-hmm. And then the green ball didn't come back to the basket, but on the second serve, what would be the likelihood of a pink?
So that's equal 1 5 times 8, right?
Well,
Well, we could do
how many pink? There's 12 pink tennis balls total, but right, my basket now has 99 tennis
12 over
balls.
99
Mm-hmm.
is 433.
Times 1/10 or
105.
1/5.
So 4 over 33 up here times this 1 over 5 or 1/65. So C.
Mm-hmm. Good. It hopefully is gonna feel better, but you did a good job. No, no, you did nice. All right. Hopefully those problems were successful for you guys too. Hopefully us talking through them was helpful. If not, hopefully you were um following along okay. We've got about 3 minutes left. Are there any lingering questions, or I'm not quite sure where you're getting all those zeros from, Phil, but
I see why comparison though, because it's better if I have someone like right here walking me through it a little bit. Thank you for that.
yeah. So yeah, Phil, I'm not quite sure how you're getting that one, but hopefully this makes sense. So, you figure out kind of your total, and then, pardon? Yeah, actually we're gonna be finished anyway. So um okay. All right. So I don't, if you guys want more practice problems, I can give you some, but hopefully this was a good little preview of probability. This is as hard as probability is going to get for the GED test. And once again, hopefully you guys agreed that once you kind of saw the process and how to do it, the math isn't too hard. Hopefully you guys agree with that. If you know how to manipulate fractions, and if you have a good kind of sense of how fractions look in other forms, in decimal or percent forms, it's going to be really helpful. It's one of the things we'll work on in July and August as well. So if you need a fraction refresher, it's coming. But any other questions or concerns, thoughts or problems? All right. Well, we'll do another lesson tomorrow, just another little snippet of one of those areas where people struggle, but we think, if we do a little practice and raise our awareness, hopefully it'll make sense. So, all right. Thank you guys for joining me tonight. And yeah, we'll see you tomorrow, hopefully. Okay. All right. Take care. Bye, lady. No problem.